Density, IGCSE Physics. Learning outcomes. Recall and use the equation ρ is equal to m by v. Describe an experiment to determine the density of a liquid and of a regularly shaped solid and make the necessary calculation. Predict whether an object will float based on density data. An overview. Just like all matter, water has physical properties that can be measured and calculated. To find the mass of water, you will need a beaker and a scale. First, find the mass of the empty beaker. Then fill the beaker up with your desired amount of water. Next, use the scale to find the mass of the filled beaker. To find the mass of just the water, we need to subtract the mass of the empty beaker from the full beaker. Our sample is 100 grams. The volume of water can be measured using a graduated cylinder. Our sample 100 milliliter. Density is calculated by dividing the mass by the volume. Plug in your measured mass. We measured ours to be 100 grams. Divided that by the measured volume, our volume was 100 milliliter. Water's density is 1 gram per milliliter. Objects with a density greater than 1 will sink when placed in water. Objects with a density of less than 1 will float when placed in water. If a block has a density of 0.1, it will float because its density is less than 1. Another block with a density of 0.5 will also float because its density is less than 1. Notice that more of the blocks is below the waterline. Another block with a density of 0.9 is also less than water, so it will float. We can see that density increases more of the block is below the waterline. Scientists have discovered that the block's density tells exactly where the block will come to rest. If the density is 0.1, then 10% will be below the waterline. To calculate whether a block will come to rest, just convert the density to a percent. Density also explains why ice floats. If you freeze water, it expands. Let's use the black dots represents the atoms in water. When you freeze water, no new atoms were added to the water. Because of the expansion, there are more rooms between the atoms. Compared to the atoms in liquid water, the atoms in the ice are not as tightly packed together, cause the ice to float. So, try calculating density of ice of yourself. It's only math. Thank you for watching.